welcome back. We are here with Scott, and he is going to talk about measuring dependency freshness. And Scott, if you are ready, I will let you go ahead and take it away.
Awesome. Thank you so much, Mary Beth. I really appreciate being here. I've been enjoying the experience so far. It's been nice to be a part of Python WebConf, and so thanks again for having me. So I'll just dive right in. Well, if I get my clicker working. So hi, I'm Scott, and I love to fix bugs. Like genuinely love to fix bugs. Some people might say they love it, but I genuinely love it. And also part of like fixing bugs and making improvements to software systems, I also really, really enjoy upgrading dependencies. And I like all of these activities so much that I co-founded a company focused exclusively on helping teams make improvements to their applications. And for years, while I thought that dependencies were important, I never really pushed my clients super hard about it. I would push really hard if we discovered there was like a known security vulnerability. But if it was just out of date, then, I figured, they would get to it eventually. It wasn't a big deal. They would upgrade when they were ready. I would, if I thought it was like impeding my productivity, I might suggest making an improvement. But it wasn't something I was pushed super hard on. And then I read this article, and I kind of let out a really big sigh, and because this is the kind of issue that could have been addressed by a more aggressive strategy for keeping dependencies up to date. Had this team had a very aggressive strategy for keeping their dependencies up to date, when the fix to this bug was released in March, then they could have applied it very quickly. And then, 143 million US consumers wouldn't have had their data leaked in May. And like, it really got me thinking, like, this is a very solvable problem. We can find a way to make it so that dependencies, get updated even automatically. I started imagining a way to, create a system that's even self-healing. So, and I do want to pause and say that it is important to consider, like, I'm going to be looking at different projects today. I'm going to be talking about different projects today. I work under the assumption that every single person on every team is always doing their best. I do not hold the opinion that there are people who show up at work and choose to intentionally do a bad job. Everyone who shows up on to work on our project, they're doing their absolute best that day, and they have lots of constraints that they have to juggle and contend with. And so, even though a breach like this has happened, that doesn't mean that it was intentional or malicious or that the team's unprofessional or anything along those lines. So I want to be really, really clear about that. So with that in mind, let's take a deep look into, kind of why does classes of errors like this happen? Why is it that vulnerabilities of this class occur so often, where it's a known vulnerability in a third-party library that gets exploited? Why is it so hard for teams to upgrade their dependencies? So one is that when I talk to teams, one that comes up over and over again is fear. And this is usually fear of a bug getting introduced when the dependency is upgraded. And most teams have a horror story in their past. Sometimes it's not even team members. Sometimes the team members who are around were not around when the original event happened, but that it's still part of the collective team memory that there was one incident, long ago, where somebody eagerly upgraded a dependency and it brought the system down for a few days. And so, that's a very rational response to, what sounds like a pretty traumatic event. You tried to do something good and it turned out to be bad. So that's worth taking into consideration, that, again, well-meaning people doing their best, don't always end up where they want to be. And then we also have time. Time's a big factor. If development teams aren't given the time to make improvements such as this, then they're not going to be able to. If it's not prioritized, if the upgrading dependencies is seen as a nice to have or frivolous or maybe risky, kind of going back to the fear, then it's not going to be, it's not going to be something that's given a lot of attention and energy to. And then there's like the perceived difficulty, like especially if a dependency introduces a breaking change, then the perceived difficulty of making that change is pretty high. And so, architecting your system to defend against breaking changes is something that is difficult to pull off. It can be pulled off, and it is difficult to structure your design to do so. And I think really kind of underlying a lot of these issues is that it's a pretty invisible problem. It's invisible, especially to the people who are paying for the work that's getting done on software systems, like people who work underneath the CFO or who have more of a financial background. Convincing them that it's important to invest in this area when it is so hard for them to see what the risk is really hard. So how can we address this issue and try to make the problem more visible? And I think this is where dependency freshness comes in. And so what is dependency freshness? Well, it's a term that was coined by Joel Cox in a master's thesis, and then also in a subsequent paper. The source information for that is down at the bottom of the screen. But it really describes and quantifies how out of date dependencies are. And it kind of creates this language for talking about how stale a dependency is, kind of using the language we would normally use to talk about how fresh something is, to talk about our dependencies. And I really like the idea of thinking about it as in terms of like brushing your teeth. So the goal, then is minty fresh software. We want software that is minty fresh. We want to take into consideration how long has it been since the last time we upgraded our dependencies. Similar to like how long has it been since the last time you brushed your teeth? That's has an indication of how fresh your breath is. Twice a day is a great habit to get into, but there are some of us who brush our teeth less often than that, and many of us don't see adverse consequences of it. But some of us do, because similar to like brushing teeth and with dependencies, being out of date can have real painful consequences. And on a software development team, those consequences are going to vary greatly depending on whether you're a developer or whether you're in leadership. For developers, we have that the system becomes more difficult to work with. The older the dependencies are, the more difficult it is to work with the system, because it is harder to find documentation that talks about the version of the dependency that you're using. There are fewer people around who know how to work with an older version. It can sometimes be harder to install, and often support for these older libraries is lacking. Sometimes they're no longer available publicly, so you have to keep a copy, kind of like almost embargo, or in a shared storage location, such as like S3 or something along those lines. I just recently was working with a client who still keeps a lot of dependencies on an FTP server internally, because they're, some of the dependencies that they're using are no longer available from the places that they got them from. And so that creates a real challenge, like for onboarding new team members. It creates a real challenge for being able to build the system, being able to install these things on newer operating systems becomes a challenge. And these are things that developers are having to cope with day in and day out. And it's often hard to see that for managers. And so when we look on the organizational side, we can see that like developer productivity is going to be affected. And that like pretty much everything we just talked about kind of falls under the umbrella of developer productivity. All of the things that make it difficult to work with an older dependency, are things that are slowing us down. And organizations do need to be aware that there are significant security risks that come into play with older libraries. And that if you don't have a regular practice in place of being able to upgrade your libraries, then when you have to do so, and you have to do so in a hurry, it's going to be incredibly painful. And I think of the adage that Martin Fowler is famous for using, which is that if something's painful, do it more often. And I think dependency upgrades can fit really well in that category of, if it's painful to upgrade your dependencies, figure out how to do it more often and do it more regularly. And then you also have like, from security, like if you hit a security vulnerability, if something like that gets found and it gets exploited, then you have PR fallouts, you have loss of customer trust. The smaller your organization is, the more likely that an event like that could like really sink the company. So we do need a way to make these problems more visible because they are pretty serious. And if we had some kind of diagnostic tool, maybe even a metric, such as LibYear, then that could help us a lot. So LibYear is a metric that is it's a single measure. It's easy to compute, easy to describe, easy to visualize, and it can help facilitate discussions around how out-of-date dependencies are. And I think one of the best sources there is for concisely describing just how the metric works is an image that's available on the libyear.com, and it describes a scenario where you have two people who are talking about like, hey, our application's really out of date, we should upgrade, and the other person's like, oh, okay, is it worse than this other project? And the other person, I don't know. But then when you're able to put some numbers to it, they're able to say, oh, well, our project is actually 120 libyears behind. And then they're able to compare that to another project that they're using, which is 42 libyears behind. And so it starts to create this vocabulary if we're talking about like how out of date your dependencies is. So we can dig in, we can think about like, why should we use LibYear? One of the big reasons is that it is easy to compute. It's very, very quick and very easy to compute and easy to understand. It distills dependency risk into a single number, which really contributes to the ease in communication. And like I said, easy to communicate. And it can provide even more powerful. Yeah, it can provide even more power when you start to graph how the value has changed over time. It can start to give you some insight into the team's behavior. So let's dig in and look at how to measure LibYear. And like, if you wanted to do it manually, like on pen and paper, or set up a spreadsheet, how would you go about doing that? So the way to do that is to look at the latest version of every package of a single package that you're using, and look at the release date for that latest version. And then look at the current version you're using, and then look up the release date for that current version. Subtract the two dates from each other, get the result in terms of years, and that's the LibYear value for that package. And then to get the LibYear for your entire project, you simply iterate over all of your packages, compute LibYear, add them all together, and you've got your total project LibYear. So nobody wants to do that by hand. It's not fun. I've done it a couple of times to test automated tools, and it's not something I advise doing. So instead, let's write tools to do that. And in the Python community, there's already a couple. Here's one that I used for the purposes of preparing for this talk. And it's been out for a few months and works pretty well. It reads from a requirements.txt file at the moment. And there are many other ways that dependencies can be tracked in the Python ecosystem. So if you wanted to use this project, I'd recommend taking a peek at dephel and using that to convert from either a pip file or something else into requirements.txt, so that you can use this to compute LibYear for your project. So here's a quick example of what the LibYear looks like for the PySpider project. And so I just checked out their repo and ran it. And we get down to a total of 69.87 years. And skimming over that, we can see that the Jinja 2 package is probably the highest on the list. And looks like requests is also pretty high, both of them around 6.5 to 7 years out of date. So, and again, this doesn't necessarily mean it's a bad thing. Like, those could be incredibly stable versions of those packages. There could be very reasonable reasons to still be on those versions. Assume really positive intent for that team. I'm not intending for this to be shaming anybody who works on PySpider. But that's just that's the data you get out of the tool when you run it. So there is while I think this tool is great, and I really like how well it formats the data in the terminal, one of the things I find lacking is that it only gives me like the value now, like right now. And so it really kind of got me curious about like, what would it look like to measure LibYear over time, and how would we go about doing that? And so I started working on a project called that I've started calling Freshly, to kind of pay homage back to the idea of like minty fresh dependencies, or minty fresh libraries. So fresh libraries, Freshly. And so built a static analysis tool that will look at different project dependency manifests from different ecosystems. Right now, there's support for PHP through Composer, Ruby through Ruby gems, a bundler file, and in Python with requirements.txt. And plans to add support for many other language ecosystems. I want to add support for node modules, both via npm and yarn, Go, many other language ecosystems that pretty much, if they have a package manager, I want to be able to use this tool to compute the metric. And if there are multiple instances of dependency manifests in a repository, then I want to be able to compute it, or I want to be able to read from it, and they kind of aggregate all those dependency values together. So, so then if we look at the PySpider example, what Freshly does is it looks at every single time that the dependency manifest changed. So in this case, the dependency manifest is requirements.txt. We go and we look at every single version of that file, and then in 1 month increments, walk forward through, or backward or forward, however you want to imagine it, and compute the libyear on that day. So, what was the libyear, the day the project was released? What was it a month later? What was it a month later? What was it a month later? And for each date in between, we're just kind of looking at like January 1st, February 1st, March 1st of all the subsequent years until we get to the present. And this can really tell us a story of how, this project's dependencies have, really kind of grown out of date over time. So they started using, dependencies that were the latest when they first started their project. And then as the project aged, the dependencies aged with it. And then somewhere along, the end of 2019, there was a huge spike, and it looks like a lot of dependencies upgraded all at once, perhaps. But this, I think, does start to highlight one of the weaknesses of the metric, in that it can be hard to, like, you can find yourself asking why, like, was there any one dependency that contributed towards that? So that was a question I had, and so I computed it out this way. So looking at every single dependency, and then list of dependencies is too long to go through. But looking at this graph, we can see that it's kind of the reason for that uptick at the end of 2019 seems to be from like a network effect. There were many packages that all came out with new versions at around the same time. And they were likely, packages that hadn't been updated in a while. And so when I think about the Python ecosystem and what might have happened at around, the end of 2019 that would have caused a lot of packages to upgrade, well, there's the end of life of Python 2.7. So one plausible explanation is that there were a lot of packages that updated themselves in response to that. I'm really not sure. I haven't dug in to do the analysis, but it does, show that, like, graphing this on your project could give you something to look at to try to find an explanation. I'd like to pause and say that this is running inside of a Jupyter notebook. Freshly is written in .NET Core, and this is using the Jupyter notebook support that the .NET framework team has been working on in the .NET interactive project. So let's look at another example. This is an example for a project called Feedben. It's a Ruby on Rails app for RSS reading. And if we look at this graph, we can see that there have been a lot of changes over time. There have been a lot of instances where the dependencies have really, kind of shot up in age, and the team has worked to pay that debt down. But they never quite reached the goal of, LibYear. When you read the entire libyear.com website, you'll discover that the people who created it suggests that less than 10 is a really good value for an application. So, this team, kind of started out below 10, but then, crept above it and, maybe only came below it once, across the life of the project. And we can see kind of a general, while there have been lots of ups and downs, so there've been a lot of efforts to pay down, kind of that dependency debt. The general trend is still increasing, and probably increasing at about the same rate that the PySpider project is. And so again, I got curious about whether or not there's any one package that was contributing to kind of these big spikes. And so did the stacked area graph for it, and we can just see a bunch of noise, and there's not really any one package that stands out and really grabs a majority of the reason for the LibYear value being what it is. So again, it looks like network effects. It looks like there are many different interrelated packages that all updated around the same time, and they're all kind of contributing to to these values going up. So I've been having a lot of fun working on Freshly, and the more I think about it, the more I want to continue working on it, and that's kind of gotten me to kind of spell out what I see as Freshly's mission and vision, kind of where I'd like to take it. And kind of my mission is to create tools that can help clearly illustrate the financial risks of deferring software maintenance. So, there are many software systems that find themselves in a situation of, dependencies being ever increasingly out of date. And these are things that the development team is often aware of. They're aware of the consequences, but communicating those is a challenge. Communicating those to people who have financial control of the project is often a challenge. And so Freshly, I want to become a tool that can be used to really kind of very clearly communicate the financial risk of continuing to do nothing on a project. And so, that's my goal. And I'm specifically using the language of deferred software maintenance, because deferred maintenance is something that, any CFO with a manufacturing background is going to be familiar with. They're going to, understand that metric, and they're going to understand that terminology and kind of the risks that are involved in it. And so again, trying to meet people who have that control and who are in those roles, meet them where they are and try to adopt and learn the language that they're using to try to help them observe that this is a problem that does need addressing. But my ultimate vision is that software systems eventually just become self-healing and outdated dependencies become a thing of the past. I see a future where within minutes of a dependency being upgraded, the continuous integration system kicks off, upgrades the dependency, runs the test suite, and if the test suite passes, deploys it into production. And you can have a security vulnerability announced and fixed, announced by a project that you're using, and then fixed in your app within a few minutes of it being released, depending on how long it takes to run your test suite. If your test suite takes longer than a few minutes, then it would take longer than a few minutes. But then that would become the amount of time that your application is at risk. Would be the amount of time it takes for your test suite to run would be the biggest factor for how long your application was vulnerable to a publicly known exploit. So, and that's kind of that's the future that I see, and that's the future that I want to help use Freshly to bring to life. So the best next steps for Freshly is I want to, really dig in and develop a metric that really takes security risk into account. I think, I really like LibYear, but I kind of want to use it as a basis of inspiration for building a metric that helps give you some indication of whether or not your dependencies have known security vulnerabilities. So find a way to take that into consideration, and that's something that I'm actively working on at the moment. I also want to find better ways to compare LibYear across projects. I've noticed from the projects that I've looked at that LibYear strongly correlates with the number of dependencies that a project has. So I can imagine a scenario where you have an application that only has one dependency, and that dependency has gotten 10 years out of date, And so that project's LibYear is 10. But then there's another project that I can imagine that has 100 dependencies, and each one of those dependencies is 6 months out of date. And so its LibYear is 50. Now, 50 sounds worse than 10, but in this case, I think the project with 10 is probably in worse shape than the project with a score of 50, because the project with a score of 50, all of its dependencies, each one of its dependencies is only 6 months out of date, which isn't bad. Whereas the other project with a score of 10, its one dependency is 10 years out of date. So I would like to try to find a way to like maybe normalize the values, based on the number of dependencies there are. And my hope is that can create a scale that's easier to compare across applications, and maybe even be able to compare across libraries. Because right now, the only guidance that's out at libyear.com is guidance about like what a good value for an app is. And, kind of in the guidance there is that it's less than 10. And I'd like to really kind of like, do some analysis and look and see like projects that I think are doing a good job at this, which ones are out there that are doing a decent job keeping up with their dependencies. Then, where do they fall? And projects that look like they're not doing a good job, where do they fall? And kind of come up with a rubric that way, and kind of create a scale for like, maybe you're doing well, you're kind of, entering an area where you should be concerned or alarmed, and then one where like you should perhaps take immediate action, maybe giving something more of a gradated scale than just get to be less than 10. So so those are ways that I'd like to try to kind of improve metrics in this space, and really kind of explore creating new metrics and finding new ways to talk about dependency freshness. And so if you'd like to get involved in the project, if you're interested, you can go to github.com/Corugbyte/freshly. Things that we need help with, adding support for more metrics, like some of the ones that I just mentioned. Like if the metric that's in the paper, where dependency freshness is first introduced, I like to implement that metric. That one's not implemented right now. LibYear is the only metric that has been implemented so far. Ones that look at security, I know there are some industry metrics that look at security vulnerabilities in score projects. It'd be nice to be able to implement a couple of those. I also want to support more ecosystems and dependency formats. So even within the Python ecosystem, right now I only have support for requirements.txt. I want to make sure that we build out support for other ways of storing dependencies inside of a Python project. I think it would also be nice to be able to detect if a Python project has switched from one dependency system to another. So if if the project is perhaps using a pip file, but the pip file only goes back 6 months, and before that it has requirements.txt, then I'd like to be able to detect that and coalesce that dependency information to create a good story across the project that way. And then improving the quality of the graphs. I'm not a data visualization expert by any shape or form. Doing my best using the Plotly library that's available through the Jupyter Notebook, and having a lot of fun with it. But finding new ways to kind of analyze the data and and graph it, and really kind of figure out a really good way to tell the story with a financial minded person, kind of in mind as being on the receiving end of the graph. But I think ultimately where I'd like to get to is that like Freshly isn't needed anymore, because every single project has a LibYear of 0. And that's an area that I know we can get to. There are tools out there that are kind of moving in that direction. Dependabot by GitHub, that GitHub recently acquired, is one step in that direction. There are other libraries like Gymnasium was bought by GitLab. It also has features that kind of move in that direction. And so like finding ways to help teams justify the expense of moving in that direction is really the ultimate goal for Freshly. And I do firmly believe that a completely self-healing system is something that's within our grasp. And when I think back to the Equifax in particular, I think just completely guessing, knowing nothing about their system, I can imagine that it would take less than $1 million to build that, right? Like, and it might take a far less than $1 million to build out a self-healing version of their platform that was hacked. And I have then, my guess is it cost them more than $1 million to address the security vulnerability. So I think, for really large organizations, kind of assessing the risk reward for moving in this direction is something to kind of help them with as well. I know quantifying risk is something that's very, very difficult and very challenging across many industries. And it's something that I'm really only starting to delve into. So if anybody'd like to go on that journey with me, I'd appreciate them tagging along. So thank you. I, again, really appreciate you having me at the conference. And if you'd like to get in touch, here's my contact info. And I've intentionally left some time for questions so that we can hop over to the gallery and have a discussion there for those who are interested.
Absolutely. Thank you so much. That was a great presentation. Thank you.
Thank you.
We've got a couple people that are excited to try it out, but
awesome.
I don't see any questions. So
Okay.
we will, I will end this in just a moment, and we will head over to the gallery so you can ask the questions face to face. You can actually see you and you can chat about it. So
Okay.
in just a moment, and we will be over there.
Thank you very much, everyone.